Now we'll go through the first theorem which is there in your class 10 for circle. It deals basically with arc. Now once you are clear with the chord and what is an arc, what is a circumference, what is a tangent, now let's go through the theorems which are given in your class 10 syllabus. The first theorem which deals with your angle property, it says angle at the center is twice angle at the circumference standing on the same arc. This is the most vital and important theorem in your class 10 syllabus. 80 to 90% of the sums where you have to find out the angles, missing angles, you have to apply this particular theorem. So it's very important for you to understand the basics and the concepts of this particular theorem. Now let's see what's given. Given angle AOB and ACB are standing on the same arc. Now look at the circle. This is the circle. This is the center. This is the arc we are talking about. What is an arc? Arc is a small portion of the entire circumference. So this is the arc. Now on this arc you have angle AOB, the angle at the center, and standing on the same arc you have angle ACB. So how these two angles are related? If there is an angle at the center as well as angle at the circumference, both is standing, that means the legs of the two angles are touching the same arc. This is the condition required. So if both these angles are standing on the same arc, then they are related. How are they related? The angle at the center has to be twice angle at the circumference. That means angle AOB has to be double of angle ACB. So if AOB is 100 degree, ACB has to be 50 degree. If ACB is given as 10 degree, then this has to be 20 degree. Now how do we prove this theorem? So let's do the proving part of it. So what are we required to prove? Angle AOB is equal to angle ACB according to the statement of the theorem. What is the construction? Let's see. Join CO and extend it to D. So from C, I'm drawing a straight line to join it at O, and we'll extend it to a point D on the circumference. Okay. Now let's go on to the proof. Look at this triangle AOC. What type of triangle is AOC? AOC is basically an isosceles triangle. Why it is an isosceles triangle? Because AO and CO both are of the same dimension, because AO and CO are the radii of the same circle, so obviously they will be equal in length. So if they are equal in length, it is an isosceles triangle, and hence in case of an isosceles triangle, base angles will be equal. So here I'm writing down, let angle OAC and OCA be x degrees, base angles of an isosceles triangle. So OAC, this one, and OCA, this angle. Both these are the base angles of an isosceles triangle. So I'm taking them with one unknown variable value, that is x degree. Next, similarly, angle OBC and OCB are going to be equal, because they are also the base angles of another isosceles triangle. Why? Because OB and OC are once again your radii of the same circle, hence these two will be equal. So in triangle AOC, I have taken the two base angles as x degrees, and in triangle OBC, I have taken the two base angles as y degree. Now come back to this angle, angle AOD. How is angle AOD related to triangle AOC? If you see, AOD is the exterior angle of the triangle AOC. And what is the property of exterior angle? Exterior angle is equal to sum of the two interior opposite. That means angle AOD is going to be sum of these two interior opposite, that is x plus x, so that will be 2x. So angle AOD is equal to 2x. Why? Exterior angle of the triangle AOC. Applying the same property, again angle BOD is going to be sum of these two angles because of exterior angle property. So angle BOD is equal to 2y. Why? Because it's exterior angle of the triangle BOC. Now look at the angle AOB. Now AOB is what? It's 2x plus 2y. It's 2x plus 2y degree. You can take 2 common. So AOB is basically 2 times x plus y. And what is x plus y? x plus y is the value of the angle ACB. So instead of x plus y, I can replace it with angle ACB. Hence, you can see that angle AOB has been proved to be double of angle ACB. So this is the way you're going to prove this theorem, and this is the most important and vital theorem. So this should be at the back of your mind while you're solving the sums. Hope this is clear with you.